Hi, in this video we are going to talk about another design pattern, which is builder design pattern. Builder design pattern is one of the creational design patterns. Okay, and before going into detail about how do we do it, what problem it solves, let's begin with why do we need it at the very first place. So there must be some problem, and for solving that we needed to build another solution which over a period of time became a standard solution for those categories of problems, similar problems, and it became a pattern. So let's begin with the problem statement first, and then we will slowly try to find a solution, and during finding that solution we will come up with this builder design pattern. So that's how we are going to proceed with this builder design pattern. Okay, so let me share my screen and show you. Let me put the topic builder design pattern. So the problem statement is something like this. So there is a class with the following properties. One, multiple member variables. Two, multiple means it will be in many. Okay, more than 5, greater than 5, and there are multiple configurations or combinations of the above parameters for object creation. So there can be many objects which can have one or many of these variables. There will be multiple combinations. And third is we should validations. We should be able to validate validations. We should be able to validate each variable. So let's start with an example. So mostly I'll write code in Python. I'll switch between C++ or Java style, but I will be predominantly writing code in Python. Okay, so let's assume there is a class, say home. Okay, so let's do in C++ Java style. So the member variables, I'll just number them. So what do you think will be there in a home? What parameters? So say there will be like doors, to windows, then there can be floors, then there can be hall, 5 bedrooms, 6 balcony, 7 dry balcony, 8 say kitchen, 9, what else can you think of, bathroom, doors, windows, floors, hall, bedroom, balcony, dry balcony, kitchen, bathroom. So let's say we have these 9 parameters, mind member variables for this class, and we need to create objects, okay, which may have one or many of these parameters. Okay, so first thing, or this is the first criteria. So if you have to create an object of this class home, so first of all, even if we don't have default values, and since we need to do validations for each parameter, so doing all of them in the constructor will become such a cumbersome job. So let's begin with a simple example. Let's see what is the problem with many multiple variables. Say if we create a object, say simple object home of this class home. So now in order to instantiate this, we'll have to pass all these 9 parameters in the constructor. Okay, So say if we have one door, so for each corresponding variable, so for the door we have one door, for the window say we have for say we write it as 2 BHK home, we create an object of that. Okay, so one door for the entry, and for each room if we have one window, say there are two windows. Then floors, say it's only one floor. Hall, they say there is one hall. Bedrooms, there are two bedrooms. Balcony, say there is one balcony. Dry balcony, there is none. Kitchen, there is one. And bathroom, say this is just one bath, 2 BHK. So now if you see this, if you create this object, so what issues do you see? First of all, after reading this thing, can you make out what parameter is passed for which argument, for which thing, if this is the order of the constructor? So if we have a constructor here, okay, and which takes all the arguments, int door, int windows, dot int floors, and dot so on. Okay, and within this we set this like this dot door equal to door, this dot windows equal to windows, and so on. So if you see, this is how we are passing. So if you see, if someone reads this class creation, will it be readable? Can someone make out by reading at this what is it doing, which parameter is going to which argument? So that's one problem number one. Next problem, it's also very error prone because of the same reason, readability. Because sometimes we may miss an argument and we can mistype an argument, so the order in which it's written, right, sometimes we miss it, and we can put a door for a balcony and balcony for a door or something like that, or the nearby variables. We generally always keep these kind of things always keep on happening in software development. So that is another problem. So this is one thing. And also say, for example, if you have true, so one is to construct this, so what are the requirements? So multiple variables, we have this configurations. So also if we need to create multiple kinds of homes, so we have a 2 BHK home, right? So say if we have a 1 BHK home, so how do we create it? So again we will have to see, you can see the problem again for creating this, right? I will have to go and check in the constructor, okay, what is the order of in the order which I have to pass. Okay, doors, okay, one door, so this is mapped here. So same order, if you follow the same order here also, this order here also, we'll see. So door, next is windows. So in 1 BHK, one room, one window. Say again floor is one only. Bedrooms, there are one only. Balcony, there is, say there are no balcony. There is no dry balcony. There is one kitchen and there is one bathroom. So if by reading these two, right, so can you make out like what parameters what is happening here? Okay, so that is problem number one. Readability and also creating the objects will be very error prone. And now if you want to validate this, say if we say if in this constructor, if before setting this variable, this dot door here, if we want to check if the door there should be at least one door for the room, right? There should be at least if door is greater than equal to 1, only then set this, right? Else we can raise an exception or something. So if we are doing such validations for each and every field, can you see how big the constructor becomes? Okay, and also if we are following, like, you must be aware of solid principles, right? So it's violating the first principle, that single responsibility principle, SRP, because the constructor is now not only used for constructing the object, but it's also doing a validations of those. So that's, well, one issue with the second thing. It's also violating the OCP, open close principle. So every time, say if we have to if we add another parameter here, okay, so say if we have, say is Okay, so guest room, we can have guest room. Okay, so say if you have to add a guest room here, a new parameter, so this constructor, this class needs to be modified, this constructor code needs to change here again, and for and anytime this anything changes in this, all these test cases need to be run so that it's not broken. And if you can see like how big it will become. So this is violating open close principle because it's open to modification. Okay, so but it should only be open to extension, and it should be close to modification. That's what is OCP. So it's violating so many things, so many solid principles, so these two solid principles basically. So let's proceed. So we have this one constructor which is having all the parameters. So there we can also do one more thing here, that, and you can see another problem. So if we say if I want to create objects here, say if I want to create a 1 BHK home, or say one studio home which has say only one room and kitchen. Okay, then I need to unnecessarily pass all those variables, but here I need only one room, so one bedroom, okay, and one kitchen. So but I will need to pass the arguments for all of the things, and then at the wherever that one bedroom is there we need to pass one, and then one kitchen. Then of course there will be a bathroom, but the others we will have to pass these variables. So making such configurations, and if we have like constructors for these combinations, so you understand how many constructors can there be. So for if there are like n such member variables, so and each one can be present or not present in that combination. So the kind of combinations, that will be number of combinations for number of combinations. So for each combination, if we have a different constructor, so number of combinations can easily be, not easily, it will be 2 to the power n, because each parameter can be either present or not present. So there will be two possibilities for each parameter, and there are such n parameters here. So it will be like 2 into 2 into 2 into 2 into 2 into 2 n number of times. So that will give you the 2 to the power n combinations. So this is the number of combinations for constructors. So there is, so writing, so if the number grows, right, so if you see 2 to the power 9 will be like 512 constructors writing. So that is again not a feasible thing, we cannot write it. So there's another way of writing one more constructor that is called telescoping constructors, where we use one constructor to with lesser number of parameters to create objects using another constructor which has more number of parameters. So if you see a telescope, right, how is it? So there is a bigger lens, then there is a smaller lens, then there is a smaller lens, and there is even smaller lens. So if you see, it is like this. And say if somebody is, and somebody is looking it from here, there is a human being looking it from here. Here's a telescope. So there is a bigger lens, then there's a smaller lens, then there's even smaller lens, and there's this is the way. So similar way, this is the, say my drawing is not so good, but I hope you get the point. This is telescope. So similarly, we can have constructors like, so we can have say I'll take home constructor with one parameter. Okay, there will be one constructor, and again home constructor with two parameters. So it, instead of writing one param, right, I can write param1, or let's use the same name. So with door. Okay, next one will be with door and windows. So what do we do here is, in this constructor we set this dot window equal to windows, and then we pass this, then we call the home constructor and pass this door object. Okay, then say we have home another constructor. This is constructor number 1, this is constructor number 2, say this is the third constructor. Now it has 3 parameters: door, windows and floor. Okay, and what do we do here is, again, so we just set the this dot floor equal to floor, say I think this should be s, and then we pass the other 2 parameters to the create this. Okay, so I hope you get the idea here. So this is, so if you see here, right, so this is having like 3 parameters, so this is having 2 parameters, this is having 1 parameter. So if you here, right, this is 3 parameter one, the bigger one, then this is 2 parameter, then this is 1 parameter, and so on. We can like go on, and this like chain can happen like with home, with say door, and like all n parameters, right? And here we can say that n parameters n minus 1 parameter n minus 2 parameter and so on, then it will be like 1 parameter. So if you see, this is what is telescoping parameter. There we have the biggest parameter, the biggest constructor with largest number of arguments will be at the end, and the number of arguments it goes on decreasing. Okay, and one constructor is called a smaller a constructor with lesser number of arguments is called in a constructor with higher number of arguments, and this is what it is. This is the telescoping constructor. So again, if you see, we are writing so many constructors for at least n constructors, and such kind of things should be, telescoping constructors should be avoided. Okay, so this is there. So how do we create these objects? Also, doing validations for each of them will be like another problem here. So if you see that this code is not readable, we don't understand, and the number of constructors here can be at maximum for all combinations can be like 2 to the power n constructors. Similarly, we have like telescoping constructors. So what's the solution? So there comes the solution comes in the form of our builder. So the builder design pattern, what we do is like it helps us create objects with the only required parameters. So if we have this one home, right, we can create a home with only just one door and one floor. Say that is our requirement hypothetically, but if we can, it can help us create this. Okay, and there's a concept, I'll introduce one more concept called, which is chaining. Chaining is like, if you see, like if you are coming from Linux background, right, so we use like this pipes. So input of one will become the output of next one, and we can like chain multiple arguments. So if you see, like we can do like if you see commands, right, we do grep minus r on some directory or file name of some pattern, right, some pattern here, and then we can do a grep again on this if we want to narrow it down, or we do like ls minus l ltr, and then we do a pipe and do cut minus d on some field, and then we can do a awk, and then we can print. So if you see, right, this kind of, so this is a kind of chaining. Similar chaining can be done in this for solving this problem too. Okay, I'll take you to the code later. So let's see how it happens. So now we can have like one home. Okay, and for each object we can have like say add door, and it will take like, if we talk constraint like door, right, I'm writing it in Python. I'll show you code also in Python. here what does it do is it will just write self dot door is equal to door, and for chaining what it will do, it will return, we will set this, and we can return self here. So this returning the self, so since this will be an this self is like this pointer, so if we return this pointer back, so this pointer is a reference to the object, and using that reference we can call the next method again. So if you have say add underscore floor, and again it will be like self comma floor, and it will be like self dot floor is equal to floor, and we return self from here. So now if we want to create the object of home, so now if you say we have one home object, and we can do like we create a home, and then we can build this object the way we want it. So we have a dummy object first, and then we can keep on building this object the way we like, and we can keep on adding features to it. So now I can add my a door to it, dot add underscore door, and say if I want to add one door here, and then I can do a dot add underscore floor, and I can add say one floor here. Similarly I can do one more dot add balcony, I can add one balcony here. So you can just keep on chaining, and whatever features you write, you can mix and match, and you can create these the way you want this home to be, your home. So similarly if we go for like 2 BHK home, what we're creating, right? So if you see this code, now it becomes so readable. 2 BHK home, I'll just create a dummy home, and now I can keep on adding features to it. 2 BHK underscore home dot add underscore, the earlier example that we had, add door 1. You remember this example that we started with, say this one, this 2 BHK home I'm talking about. So there was one home, one door, 2 windows, and this one. Similarly, so we can, when we write those methods, dot add door 1, then we can do dot add windows 2, then we can do dot add underscore floor 1, and so on. I hope you get the point. And in each method, say for example we have this our add door, this method, right? So here if I can do the validation also, and each method will have its own validation. So if door is okay less than 1, then we can raise an exception here, raise at least one door required, okay, else set self dot doors equal to doors, and return self from here. Okay, so this is the whole idea of this code. So I'll share my screen again and walk you through the code. So I hope you get the point. And then even like if you see here, like this validation will all be limited, will be restricted to this method itself. So now our code, each method had its own responsibility, that is it's not validating single responsibility principle. Also whenever if you want to add a new method, or like this problem we had, right, adding a guest room, so we just need to add another method here, add guest room. Okay, add that member in the that member variable, and just add another guest room. So it's now it's satisfying our open close principle also. It's open for extension. We can just add new features here, add one more feature, add member variable, and we can just keep on doing. So I hope you get this. Now let me walk you through the code. So this is, I have this on the screen, a sample code. So here this class home, this code is in Python. So if you see the constructor here, so I have these many parameters. So there are some integers and some bools too. So I have doors, windows, bedrooms, balcony, floors, and has guest rooms, etc. Has garage and has swimming pool also. So these are like some bool values which we can have in the room. And then I have created so since I have to return self everywhere, so I've created a decorator which can be used for each method instead of repeating that return self everywhere. So this decorator, what will it do? It is, it will just return self here. So this is the what it will call the function with all the arguments that's being passed, and it will return self. So this is what this utility is, what it will be adding to all the functions by using this decorator here. So if you see here, I have the methods add doors, add floors. So if I have checked here, so if door is less than 1, there is an exception. Okay. So similarly, if it has swimming pool, now if you see here, right, so I have created a home 1 with home, and I have added doors, added floors, added swimming pool, added balconies. And in Python there's a utility where if you see do where's home, right, it will print whatever variables it has. And I have created another home which has add balconies 2, add swimming pool 1, add doors 2, add floors 5. I have just add 5 floors, I don't know why, but add garage. Since this is the bool add garage, so I'll just set it to that self has garage is true. So this is how it is. And if I'll execute this once and I'll show you. So if you see the output, right, let's see, if you see here, since I'm printing this home 2 dot bedrooms, this bedrooms attribute is not present in home 2 because we have not added that bedroom in this room. So that's why when you're printing it, it throws an error that object has no attribute bedroom. So this gives the validation we will have only those attributes or those member variables in the object which we have added or which we need. Otherwise we could have gone with initializing all the variables with a default value and such that all the objects have all the member variables, right? But if you see in a fairly large objects, that's like waste of space, and you're unnecessarily creating large objects which will never be utilized for just. So that's the idea. If many of you might be thinking about why not initialize everything with a default value and use whatever it is. So you won't have the validations then, and plus each object will have all the member variables, which is like waste of resources, that's not needed. So if you see here, so that's why I printed this object has no attribute. Now if we remove this and run it again for you, if you see the first home, right, it has 4 doors. I'll bring it here. So I have added 4 doors, so there are just 4 doors. There are 2 floors, we have added 2 floors. I have added a swimming pool here, so there is a swimming pool here. Have swimming pool is true, and I have added 3 balconies. So if you see, there are 3 balconies there. And the second home, we have added 2 balconies, so there are 2 balconies here. It has swimming pool because I have added a swimming pool here, that's why it's set to true. Doors, we have 2 floors. I don't know why I have added 5 floors, but there are 5 floors. And then we have add garage, and add garage has garage is true. So now if you see these 2 objects, when we are printing these variables, these 2 objects what we have, so it will only have those variables which we have added here. There will be no extra variables. So that's why there's a utility in Python where we can use to show what all members are there in a method in an object. Okay, and this is our client, and it can use the way it is, and also it's extensible. So now I can add any method here, any new a new member variable here, and I just need to add a method here, and it's incremental. Every time I can keep on adding features, and it will be backward compatible. My previous clients won't break because they don't need to know what's happening in the future. So that's all about builder design pattern. Thanks.